Hello everyone. As promised, and now that I've finally gotten my computer all up and running and good, I will do a quick rundown of the shortcut rays for optics for curved mirrors, both concave and convex. So the first one we're going to start with is when an object is behind the center of curvature. This also works for in front of the center of curvature, but we'll start here. So I will do the incident rays in blue, and I will do the reflected rays in red. So the first one that we talked about was when it is parallel to the main axis, which is essentially just straight. And we know from several attempts and proofs and looking at the angles and whatnot that the reflected angle rather is through the focal point, right? So there's one. The second one is, of course, the incident ray going from the top through the focal point, and then, of course, the reflected ray is then parallel to the main axis. All right. And really, those are the only ones you need. You will need at least two rays to make a ray diagram. But should you choose to make a third, it would be the one going through or from the top of the object through the center of curvature, thusly. And theoretically, it should intersect with the rest of them. Obviously, the diagram that I made is slightly off, but you get the idea. And so you end up with all, and of course, if it goes through the center of curvature, it reflects back on itself. So I guess there should technically be another ray going from here and going back along this one. And so you end up with one reflected ray going this way and the incident ray going this way for this one. Alright, and so those are the three rays. And of course, now everyone seems to have a trouble with the way that this object is going to appear. Right? We know that since these light rays are coming from the top of the object, that the top of the object is going to be here, which I'm going to do the object in green, the image, sorry. So the top of the image is going to be here, but the question is, where's the bottom of the image? So some people have drawn it here below the point. This is obviously not true. What you do know is that if you were to take a point from the bottom here and reflect it, have the incident ray going along the main axis, obviously it would reflect back on the main axis. So in other words, the bottom of this arrow has to be somewhere on the main axis. And since we know the top is here and the bottom is along the main axis and it is a straight arrow, then we can see that the image forms here. And you realize now that the image is shorter, it is also upside down or inverted, and it is in front of the mirror. This is what is known as a real image, meaning that we can project it onto a screen. So just to sum up, the first one is when the incident ray is parallel to the main axis, and the reflected ray goes through the focal point. The second one is when the incident ray is through the focal point and the reflected ray is parallel to the main axis. And finally, the third one is when the incident ray is through the center of curvature and the reflected ray goes back on the center of curvature. And for this instance, when the image forms, it forms in front of the mirror where the reflected rays intersect, so where all the red rays intersect, and it creates a real image. Alright, so let's move on to the next one, being a concave mirror with the object in front of the focal point. So in other words, with the object being here instead of behind the focal point. Now, if the object is here, you can no longer draw rays going through the focal point or through the center of curvature because they're behind the mirror, and if a ray goes through the focal point, then it will not hit the mirror. So we have to be a little creative. But before we do that, we can still go with our good friend, the parallel, when the incident ray is parallel to the main axis, then it will reflect through the focal point. this still holds true for this instance. So that's the first one. For the second one, now we have to be a little bit more creative. So if we were to have some object, let's say down here, right, and the ray were to go through the focal point, it would come out back and reflect parallel, right? So what we can do is we can pretend like there is a ray coming from the focal point, right, and then eventually, obviously, originating from here and coming as if it were going through the focal point. So something like that. And then, of course, the reflected ray would still go and reflect parallel to the main axis. And you can also do the third one, which is the one coming from the center of curvature. So sort of the same thing, where it would, quote-unquote, originate from the center of curvature and come from here, and it would reflect back on itself. I'm going to leave that out for now because it works the same. Now you'll notice that these arrows don't intersect anywhere behind or in front of the mirror, right? This will go on forever this way, this will go on forever this way, and they will never intersect. So there's no place where these two arrows will actually meet. But much like a flat mirror, if you were to trace the reflected rays back behind the mirror, pardon the sketchy writing, right? So if we take this green and follow it back here, you see that there's a point here where they intersect. This is where the top of the image is. It forms here. So now, rather than having a real image, we have a virtual image because it is behind the screen and it is upright. So just to sum up, the three, but we're going to start with two rays, the shortcut rays for a concave mirror with the object in front of the focal point. The first being where the incident ray is parallel to the main axis, the reflected ray is through the focal point, obviously. The second one is now slightly different, where the incident ray originates from the focal point, quote unquote, and it reflects parallel to the main axis. So this ray sort of kind of starts from here, and then we pretend as if it came from the focal point and just goes straight ahead. And the third one is, of course, when the incident ray originates from the center of curvature and the reflected ray goes back through the center of curvature. So it would come from here, go this way, and then come back. And so to create the image for this type of setup, you would have to trace the reflected rays back into the mirror, which is what we did here, and the image itself forms at the intersection of these reflected rays. Okay, and finally, we will do the convex mirror. So now instead of the object being here, it is going to be back here. All right, and so now things change yet again. So we can start off with our usual ray parallel to the main axis, but now it's not going to go through the focal point because this is a mirror, obviously, and it can't go through it. But what does happen is that you end up with a ray that sort of looks like it goes through the focal point, but then reflects back out. So it actually goes something like this. So it's a reflected, this is the actual ray itself. So it is reflected as if it comes through the from the focal point. So it looks something like that. So now we can do something similar with one of two rays, either the ray that points towards the focal point, sort of aims at the focal point, or the ray that aims at the center of curvature. Obviously, you don't have to draw them and then erase them. I do because I don't have a choice. And so now the one that points towards the focal point, the lower one, is simply going to do what we expect and reflect back along the center of along the main axis. This one, the one that points towards the center of curvature, is pointing sort of along the perpendicular line, and so it will reflect back on itself, as they always do. And so those are the three shortcut lines. Now, you'll notice again, these three reflected rays will never meet never meet on the same side as the object, right? So there will be no real image here. It will be a virtual, it'll be a virtual image. So what we do now is the same as we did before, and we trace these rays, the reflected rays, back through the mirror. So this one will go through the focal point. This one will go through the center of curvature. And this one will go straight back. And so what you should end up with, had I drawn it sort of accurately, would be this point right here. And so our image forms here. And so you'll notice that the image is small and upright and forms behind the mirror. This is now the shiny point of the mirror. This is the shiny side of the mirror, which means this is sort of behind the mirror. And so the image that forms is upright and virtual. So again, just to sum up, the first one is when the incident ray is parallel to the main axis, which is this one. Then the reflected ray points away from the focal point, so like that. The second one is when the incident ray is pointing towards the center of curvature. The reflected ray goes back on itself away from the center of curvature. And finally, the third one is when the incident ray points toward the focal point. The reflected ray goes parallel to the main axis. So this line goes towards the focal point and reflects away from the main axis. And now in this one, like the previous one, you trace the reflected rays back into the mirror, and the image forms at the intersection of the reflected rays, and this creates a virtual image. Okay, I will put a link up on School Fusion containing these 3 slides, summarizing all this information, and hopefully this will help you study for your test. Good luck, and see you soon.